Hello everyone, welcome to my class. I hope all of you and your family are in good health. Now, today we solve the last two problems of exercise 1.1. So, let's see the question number 4. Now, the question number 4 is use Euclid division lemma to show that the square of any positive integer is either of the form thrice m or thrice m plus 1 for some integer m. In this problem, hints is also given. So hints is let x be any positive integer, then it is of the form thrice q or thrice q plus 1 or thrice q plus 2. Now square of each of those, that's mean thrice q plus 1 and thrice q plus 2, and show that they can be retained in the form of thrice m or thrice m plus 1. In your question, retain any positive integer. Okay, so at first we take let b any positive integer be a. Let a be any positive integer. Okay, so a can be written as a equal to b cube plus r. If we compare a equal to b cube plus r with thrice q plus 1 and thrice q plus 2, then definitely b equals to 3. So we divide a by 3, then possible remainders are either 0 or 1 or 2. Then a equals to thrice q or thrice q plus 1 or thrice q plus 2. Now question is after squaring of those numbers, that's mean thrice q plus 1 and thrice q plus 2, rewritten in the form thrice m and thrice m plus 1. Now a equal to thrice q. Now after squaring, that's mean thrice q square, that's mean 9q square. Okay, so 9q square can be written as 3 into 3q square. So if we take 3q square equal to suppose m, that's mean 3m, that's mean thrice q square can be written as in the form of thrice m. Okay, similarly for thrice q plus 1 and thrice q plus 2 can be written as in the form of thrice m plus 1. Okay student, now see the actual answer. Okay, I think everything is clear, the basic is clear. Now see the answer. So let a be positive integer and we take b equals to 3. So if a divide 3, then possible remainders are either 0 or 1 or 2. So a be any positive integer and b equals to 3, then a equals to 3q plus r for some integer q greater equals to 0 and r equals to 0, 1 and 2, because 0 less equal to or less than 3. Okay, is it clear? Now a equal to thrice q or thrice q plus 1 and thrice q plus 2, that's mean thrice q plus r when r equals to 0, then thrice q when r equals to 1, that's mean thrice q plus 1 when r equals to 2, then thrice q plus 2. Now square of those numbers thrice q plus 1 thrice q plus 2. So a square equal to thrice q square, that's mean 3q thrice q whole square, that's mean 3 into 3q square. Okay, so 3 into 3q square, where equal to 3 into k1, where k1 equals to 3q square. First one k1 equal to 3q square. Similarly 3q plus 1 whole square, that's mean a plus b whole square form. So 9q square plus twice ab, that's mean 6q plus 1. So if we common 3 from first two terms, so 3 common, that's mean 3q square plus 2q and plus 1 remaining. So 3k2 plus 1, where k2 equals to 3q square plus 2q plus 2q, and the last one 3q plus 2 whole square, that's mean a plus b again whole square form. So 9q square plus 2ab, that's mean 12q plus 4. Now plus 4 can be written as 3 plus 4. Okay, that's mean 9q square plus 12q plus 3 plus 1. From first three terms we common 3, then this is 3q square plus 4q plus 1 and 1 is remaining. Again this term equal to k3, so 3k3 plus 1. Okay, now first one is 3q square can be written as 3k1, where k1 equal to 3q square. Again second term 3k2 plus 1, where k2 equals to 3q square plus 2q, and the last one 3k3 plus 1, where k3 equal to 3q square plus 4q plus 1. So 3q square written as in the form of 3k1, 3q plus 1 whole square can be written as 3k2 plus 1, and 3q plus 2 whole square can be written as 3k3 plus 1. So here k1, k2 and k3 are positive integers. Okay, are positive integers. So if we write m, then that's mean k1, if we put k1 equals to m, k2 equals to m and k3 equals to m, then this is thrice m, this is thrice m plus 1, this is again thrice m plus 1. So that's mean the square of 3q square, the square of 3q and square of 3q plus 1 and square of 3q plus 2 can be written as in the form of thrice m and thrice m plus 1. Okay, now next problem. Now question number 5. Use Euclid division lemma to show that the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. In this problem, simply one change is there. Previous problem, square of any positive integer, and in this problem, cube of any positive integer. Okay, here is cube. So student, in this problem one change is cube. That's mean again we take a be any positive integer and a can be written as a equal to b cube plus r. Again we take b equals to 3, that's mean 3 cube plus r. Since b equal to 3, that's mean divisor is 3, then therefore the possible remainders are either 0 or 1 or 2. So a equals to 3 cube plus 0 or 3 cube plus 1 and 3 cube plus 2. So here simply cube of this number, that's mean cube of this number, again cube of this number and cube of this, write in the form 9m, 9m plus 1 and 9m plus 8. So see the actual answer. So a be any positive integer and b equals to 3. So by Euclid division algorithm we have a equal to b cube plus r, where 0 less equal to r less than b. So if we take b equals to 3, then a equals to 3 cube plus r, and since 0 less equal to r less than 3, since b equal to 3, then r equals to 0, 1 or 2, then a equals to thrice q plus 1 and thrice q plus 2. Now cube, that's mean a cube, so that's mean 3 cube whole cube, that's mean 20, so 7 q cube. So 27q can be written as 9 into 3q square. So again 3q square equal to, we take n, that's mean 9n. Similarly 3q plus 1 whole cube. Okay, so 27q cube plus 27q square plus 9q plus 1. So from first three terms we common 9, that's mean plus 1 remaining, that's mean 9t plus 1, where t equals to this, here n equals to 3q cube. Similarly 3 cube plus 2 whole cube, that's mean here is 9k plus 8, where k equals to 3q cube, 3q cube plus 6q square plus 4 cube. Okay students, if you write directly 3 into 3q cube, that's mean 9 into 3q cube, directly 9m. Okay, where m equals to 3q cube, and here 9m plus 1, where m equals to 3q cube plus 3q square plus cube, this is also right. Okay, and here 9m plus 8, where m equals to 3q cube plus 6q square plus 4 cube, this is also right. If you directly write this is 9m, this is 9m plus 1, this is 9m plus 8, then no problem. Okay, now the cube of any positive integer is of the form 9m, 9m plus 1 and 9m plus 8. Okay, now exercise 1.1 complete. I think this class was helpful to you and you have understood the things. Okay student, thank you.